So how do you find the derivative of the inverse function of a given function without actually finding the inverse, right? This is how you usually go. You got to start by writing something like this. So if you apply f to the inverse of f on x, you get x back. Just think about it. You have x, you apply the inverse, and then you apply f back. Those two, one undoes the work of the other. They cancel out, and you get x back. Now from this equation, you can use the chain rule by deriving the equation on both sides. So that's technically first implicit differentiation, deriving the equation on both sides. So the right hand side would be 1, and the left hand side, and let me move this over a little bit, the left hand side would be, by the chain rule, the derivative of the outer function applied to the inner function times the derivative of the inner function. Okay, so this here, the derivative of the inverse is exactly what we want. So that means f inverse prime of x is 1 over f prime of the inverse applied on x. Now we're given the point. We know that x is 622. If we were not given this point, we would have to, using this inverse or this regular original function, we would have to find the coordinates of the point. But right now we know the point, so there's no confusion. That means f inverse prime of x is 1 over f prime of f inverse of 622. And since the point x is 622 has coordinate y 5, that means f inverse of 622 is 5. So this is 1 over f prime of 5. This is going to be the answer to the problem, but I don't quite know what f prime of 5 is, so I'll calculate that here. So f prime of x is, by the power rule, 24x squared minus 30x. So that means f prime of 5 is 24 times 5 squared minus 30 times 5. So 24 times 25, I'll use my calculator for that. It's not that difficult, but I'll do my calculator anyway. 600 minus 5 times 30, that's 150, so that's 450. And therefore, if I go back, f inverse prime of x is 1 over f prime of 5, so it's 1 over 450, and that's the answer to the problem.